Minasan, konnichiwa, Zamurai Engineer desu. In this video, let us continue with Chapter 4 of our topic about simultaneous equations. Numerical solution is Gaussian elimination with partial pivoting. So let us again have an example. So we have already about 2 examples for Gaussian elimination, and we have another one with partial pivoting, and these are the given simultaneous equation. So we have 10x1 minus 7x2 is equal to 7, negative 3x1 plus 2.099 x2 plus 6x3 is equal to 3.901. 5x1 minus x2 plus 5x3 is equal to 6. So take note of the highest number of significant figure is what? 4. So we will have to calculate at least 4 significant figures. So in matrix forms, we have the following: square matrix A, then the variable matrix, variable vector X, and the constant vector on the right side. So using Gaussian elimination with partial pivoting, using 5 significant digits with chopping. So instead of 4 significant figures, let us add in order to extend the precision and allow some sort of added accuracy. So continue with the solution. Step 1, examine the values for the first column. So we have the first column as what? 10, negative 3, and 5. And take note that we are actually having the absolute value. So the largest absolute value is 10. So that is the coefficient which will be used as partial pivot. So, and that value 10 is the coefficient of the first term of the first equation. So let us follow the rules of partial pivoting, which is row 1 with row 1. It doesn't switch because it is already in the row 1. Okay. In other cases wherein the highest absolute value is not in the row 1, we have to switch it to become row 1. So that is our process of partial pivoting. So switching that, then perform forward elimination. That is the step 1, forward elimination, meaning we have to eliminate the first term of the second row and the third row. Okay, so just like in our previous example, we can do that by what? How to do that? The first row multiply by 3 and divide by 10. So it will become 1 here, then 3. So add to this, so it will become 0. And for the elimination of this 5, we have to multiply by 5 and divide by 10. Then this will become 5. And then subtract. So subtracting to 0. So multiplying and dividing all of the terms of the first row. This one, this one, this one, this one, this one. As similar to what we had on the previous example. Okay, so doing that, we have the following. result for the first forward elimination, meaning we eliminated the first terms of both the second row and the third row. So we have this one. So we need now to what? To eliminate the other or the second coefficient, second term coefficient of one of the equation. In this case, we will select. Okay, we will select because we have what? We have to compare. Okay, we have to compare this one and this one. So let us continue. Forward elimination. Step 2, take note. Okay, take note of that. Okay, so we what? We switch this one with this one. We switch. So that's why it became like this. Okay. So the second row is now 0, 2.5, and 5. Okay. 0, 2.5, and 5, and 2.5. So we have what? 0, 2.5, and 5, and 2.5. So we switch the second and third row. Okay. And then after switching it, we have what? We have to eliminate this one. We have to eliminate it using this row, and actually particularly using 2.5 as our pivot. Okay. So doing just that, we have the following. Result, and you'll notice that we are able to get the upper triangular matrix that we want. Okay. So that is the end of our forward elimination. And then the next step is back substitution to be able to get the values of the variables. So back substitution meaning let's start with the bottom, this one, so that we can find out the value of x3. So that is 6.002 divided by 6.002, that is just equal to 1. So in the explanation, the book states that we have to use 5 significant figures, but here we are actually doing it in 4 significant figures. Okay? I don't know why, but we can, in our own manual or handwritten computation, we have to do 5 significant figures just to check, just to have an added precision. Okay. And then after finding out the value for x3, we have to back substitute so that we can find out the value for x2. So we have the value for x3, which is equal to 1, then back substitute to be able to find the value for x2. Okay, and doing just that, so this is 1, so 2.5 minus 5 is negative 2.5 divided by 2.5, that is negative 1. Okay, so we are already able to solve 2 values. Therefore, the last variable is x1. We have to find out by substituting the values for x2 and x3, which are 1 and negative 1. So doing that, this is negative 1, this is 1. So negative 1 times 7 is negative 7 plus 7, that is 0. And minus 0 times 1 is 0. So 0 divided by 10 is 0. So these are the values of our variables. Okay. So compare the calculated and exact solution. The fact that they are equal is coincidence, but it does illustrate the advantage of partial pivoting. Okay. So calculated and exact. So just by doing it in what? 4 significant figures, we are able to do our calculated values to be correct. And that's all about our example. Please do this example manually and trying to follow the instruction and explanation while doing it. Doing properly the steps of particularly the upper triangular matrix, okay, while implementing the partial pivoting. Okay. So again, this is Dr. DrEYPEI, preaching engineering for nation building.